So again, thank you so much for joining. We waited even 3 minutes just to allow late arrivals, and I think it's more than enough. So we'll start now with our live webinar by Automat-it together with mokSa.ai and AWS. Topic is reach faster time to market with our DevOps best practices for startups. My name is Yoav Marcus, and as you can see here in my title, I'll be your moderator for today's session. So whether you're dialing in from the UK, Europe, or elsewhere, thank you for taking the time to be with us. Today's session is all about helping startups like yours move faster, smarter, and more efficiently by applying real-world DevOps best practices. So over a bit less than 60 minutes, you will gain valuable insights, hear success stories from one of our customers, and walk away with actionable strategies to speed up your time to market. With me today, our honorable guests, we'll start with Kranthi, CTO of mokSa.ai, who will share hands-on insights from the startup front lines. Hello, Kranthi. As well, we have Elior from AWS, a leading voice in cloud-native DevOps practices. Hey, Elior. And last but not least, our own Oleksii, DevOps expert and an AWS ambassador, part of our Automat-it company, brings deep experience in helping startups scale their infrastructure and operations. So what you can expect today: deep dive into DevOps methodologies, customer case studies showcasing real-world DevOps transformations, AWS best practices that can help you build and deploy faster. Towards the end of this webinar, we will host a really short Q&A session about between 5 to 10 minutes. So if you have any questions during the talk, please use the dedicated Q&A button at the bottom of the Zoom window, and we'll address as many as we can. And lastly, after the Q&A session, we'll also have a really short online raffle where one of you can win a 100 Amazon gift card as part of the online raffle. And also, quick note, this webinar is being recorded, so don't worry, we'll share it after the end of the session. So I think that we're ready to go. And Elior, stage is yours.
Hi everyone. My name is Elior. I'm a solutions architect at AWS. And in my previous roles, I worked as a DevOps engineer and also managed a DevOps team. And today we will be talking about DevOps best practices. And in the next 15 minutes, I'm going to focus on compute and container services on AWS. Now, because there is probably a diverse experience levels in the audience, I will briefly cover the fundamental concepts first, and then I will proceed to more advanced topics. So let's begin with containers. Next slide, please. So over the last decade, containers have become increasingly popular, offering many advantages for production and development environments. Is anyone here new to containers? You can raise your hand or let me know in the chat. Okay, so I guess, okay, I see some comments in the chat. Okay, so I will briefly cover the concept quickly, just so everyone will be on the same page. Can you please click another one, Yoav? Thank you. So containers package the application into a single deployable artifact. It encapsulates the code, runtime version, code packages, and system configuration into one container image. This image is an immutable version of the application that can be run on any environment. Let's see an example. Click, please. So a local development environment typically has everything you need to install, develop, test, and build your application. However, there is no guarantee that the same components will exist on your staging environments and production environment, of course. For example, runtime versions or packages may be different. The more environments you have to manage, the more challenging this becomes. many engineering hours can be spent troubleshooting these kinds of problems. And containers solve exactly this issue. So another click, please. If we need to pick top 5 advantages of containers, it will be portability, efficiency, isolation, faster development, and scalability, because it's easier to manage and scale with orchestration tools like ECS and EKS. And now that we all agree that using containers is beneficial, let's move on to how we do it on AWS. Another click, please. So the choice of the orchestrator is important. It will have a deep impact on your future as a startup company. And one of the most common requests I hear from customers is help me decide which container service to use. Now, it's no secret that Kubernetes is the most popular container orchestration in the industry. And I bet everyone here in the room at least heard about it in the past. While AWS provides a managed way to run Kubernetes on EKS, it still requires expertise and knowledge, management, and operational overhead. For example, cluster upgrades, plugins management, and all of this stuff. It also costs money. And for startups, my recommendation will be usually choose the service that is easier to operate and manage. And in this case, I think ECS will be usually a better option, especially if you don't have the manpower to invest in operation and maintenance. Next slide, please. So why startups tend to choose ECS? The way to production is fast because of the fully managed control plane. There is simple integration with all common AWS services and features like IAM, CloudWatch, load balancer, security groups, ECR, and more. It is proven in scale, performance, and security, and it has the best TCO, which means total cost of ownership, and overall is a very good way to go to production fast. One more thing to remember, there is no control plane management overhead. And in Kubernetes, you have to upgrade, patch, and manage your Kubernetes software all the time. With ECS, everything is fully managed. For example, in Kubernetes, you need to do Kubernetes version upgrades and plugins. Maybe you manage, I don't know, 10 plugins, and you need to make sure it's everything compatible with Kubernetes version. So this is this point. And one last thing, ECS is free. Next slide, please. Now, I know life is not always simple and the spectrum of choice is wide, but the equation is simple. The more flexibility, the more operational overhead, and the less flexibility, meaning less operational overhead. For example, serverless solutions are always easier to manage, but they sometimes limit users in choosing their computing resources. Now, again, I understand reality is not always simple, especially in the DevOps domain, and you might be an experienced engineer who is familiar with Kubernetes and prefer using it, or you might be a junior engineer who wants to keep up with the pace of technology. So if Kubernetes is your preferred way for running containers, let me briefly introduce EKS Automod. Next slide, please. So EKS Automod was launched in the last re:Invent 6 months ago. It simplifies the management of EKS, freeing the user from operational overhead of managing clusters. It means add-ons management, cluster upgrades, auto-scaling, and all of this stuff is managed by AWS. In this session, we won't go deep into EKS Automod because we're short on time, but I still want you to have the basic understanding about EKS Automod. So next slide, please. So today, the classic EKS architecture looks like this. Okay, you can see in the left side, this is the managed control plane that is managed by AWS, and the right side is the blue, which is the blue side, is managed by the customer or the user. Now, to run the application, the user needs to install a series of add-ons in their cluster, as well as provisioning EC2 instances if you use Carpenter or managed node groups to host the pods and the applications. And you also need load balancing services and EBS volumes. And you might be looking at this and think it's quite complicated, and you are not wrong. So one click, please. Next slide. So let's have a look at the new architecture with the EKS Auto Mode. As you can see, with EKS Auto Mode, AWS takes more responsibility, and AWS will manage the core EKS add-ons, the lifecycle of nodes, auto-scaling, and more. Now, again, in this session, we won't go deep into EKS Auto Mode technical details, but I think we need to see one more thing. So let's go to the next slide, please. Okay, next slide, because I don't have time to cover this. Okay, so I want to compare the two shared responsibility models. This is the previous shared responsibility model. In this model, the customer had more responsibilities, and the operational overhead was quite time-consuming, especially if we are talking about startups. So you don't have the manpower to manage everything. And let's see the next one. So as you can see with EKS Auto Mode, you have only two things, only the two rows above you need to take care of, which is VPC infrastructure, cluster configuration, and non-basic add-ons. So if you use Argo CD, or if you use service mesh like Istio or Linkerd, these add-ons you still need to manage, but everything else is managed by AWS. Next slide, please. So if we need to summarize, the first thing will be use containers. The second thing will be choose your tools and services carefully and think about the future. Always calculate TCO, total cost of ownership. Don't find yourself provision 10 clusters of EKS because it's cool and it's the top cutting edge technology, and then you will regret it because you don't have the manpower to manage it. So if you need to choose an orchestration platform on AWS, I would generally recommend ECS or EKS Auto Mode as the orchestrator. And last but not least, consult with your partner or AWS. We can always help. And I think that's it. Oleksii, to you. Take it from here.
Yeah. Hi, everyone. My name is Oleksii. I'm DevOps expert and AWS ambassador from Automat-it, Cloud Center of Excellence. Automat-it is a premier partner of AWS, and we work mostly with startups. And my part of presentation today is about infrastructure as code, CI/CD, and GitOps. When we are talking about a startup, we usually think about a group of people who focused on some specific idea, some problem, and releasing the solution for this problem as soon as possible. And market fit and being faster than competitors are necessary for startup survival. At this point, people are focused on the product and features, not on infrastructure, automating processes, or security. But when the company releases the first MVP and gets the first investments, they has to make decision where to host the application. And public clouds and AWS in particular for startups nowadays are the most popular place where to host the application. AWS provides fundings for startup, and a company don't need to care about, don't need capital investments into infrastructure and can get virtually unlimited capacity just in several minutes, and also stop using and stop paying for it immediately. But when startup starts using cloud, it usually manual approach, or informally called ClickOps. For example, company needs virtual machine called EC2 in AWS, and the first place where they go is Web UI. When you open Web UI for EC2, you can see a lot of different configurations, like operational system, hardware, storage, networking, security configuration. And in general, cloud usage looks like this. Person just logins to Web UI, clicking something, creating different services, and there is one pros, it's fast to start. But there are more cons because it's high probability to make mistakes in such approach, no consistency, and no visibility. You don't know who and when and what changed in your infrastructure. And at this point, we as a DevOps company comes in and start implementing infrastructure as code. Infrastructure as code is a practice that allows you to create your infrastructure using code instead of manual clicking. And there are many products on the market nowadays. The most popular of them are Terraform, CloudFormation, AWS CDK, Pulumi. They may have different syntax, but logic is the same. And the first stage when we start implementing infrastructure as code, we writing, we defining cloud resources in the code, store the code in Git, and execute this code locally. And our tool just calling AWS API to create cloud resources. So we have more consistency here and easy debugging because we execute code locally. But we need some skills here. If company didn't work with infrastructure as code before, they need to learn new tool, new syntax. We still have drift risk because if anybody in the company still changing something manually, we have drift. And lack of auditability because usually current state of infrastructure doesn't contain a person who actually did changes. And samples of infrastructure as code, Terraform, we see the same example with virtual machine with EC2 instance. We have the same settings as we see in Web UI, but we also can use variables, can refer to other services created earlier, and also write modules for code reusability. Or another one is AWS CDK, which supports different popular programming languages like Python, Node.js, Go, Java, and usually code may look similar for developers, but logic is the same. We define cloud resources and deploy them. And another stage is infrastructure as code, plus GitOps. In this stage, we actively using Git. We're storing infrastructure as code in Git repository, and we also add automation. In this example, it's GitHub with GitHub Actions, where we add code tests, security scanning, and our code is executed from the pipeline. And this is best practice because Git is used as single source of truth. We can version our code. We can automate testing, and this approach is more secure. And this is example of how this may look like in GitHub with GitHub Actions. So we create pull requests, different automation steps are executed, and if everything is passed, we can merge our changes. And how modules can be versioned and releases created. Example of popular public Terraform module for EKS. And later, when we call the module, we can call the particular version of it. And when it comes to application deployment, usually startups also start with manual approach. Doesn't matter where the application is hosted, it's EC2, some container service, or serverless stack. Application is updated manually. And pros and cons are the same as we had in the manual approach for infrastructure as code. It's fast to start, but we can make mistakes and we don't have consistency and visibility. And here is CI/CD approach comes in, continuous integration and continuous delivery. It's approach that allow us to standardize our software development lifecycle, reduce number of mistakes, and make the process faster, actually. We start with using feature branches for different changes. We actively testing our code. We use different environments, including several non-production, and only after successful tests, we deploy code to the production. And example of how we build CI/CD for Kubernetes workloads, because Kubernetes is a bigger part of our stacks for startup. The application code is stored in Git. We have automation pipelines, which also test code, perform security scanning. Then we automatically commit changes to another repo for Argo CD. And Argo CD is thinking Kubernetes cluster, Kubernetes services with the Git repository. And another other best practices for containers, also use multi-stage builds and minimal base images. This will allow you to have smaller containers, and your application will be deployed faster and will be more secure. Avoid using latest tag, because this may break your pipeline sometime. Use approach of image immutability. So don't rebuild your images for every next environment, just retag images. And GitOps approach, just use Git as a single source of truth, and use tools like Argo CD for continuously thinking configuration between Git and live Kubernetes workload. And summarizing everything, how to make our way to market faster, use infrastructure as code, CI/CD. Don't forget about security. We have a lot of security tools on the market. It can be AWS native or open source. And also worth mentioning, maybe not for the first stage of the startup, but when we deploy to the production, we should think about observability, about monitoring and logging. And AWS advisor tools can also help you a lot. For example, Trusted Advisor, Compute Optimizer, or Security Hub. They make good recommendation for you. And we also have a manual for DevOps for startups. We will share these docs after our event with all participants. And feel free to connect with me on LinkedIn or via email if you have any questions later. And now I'm passing to one of our customers, Kranthi.
Yes, thank you so much, Elior and Oleksii, for sharing us very insightful presentation with us today. Yeah, today I'm going to be talking about how all the best practices that was laid out by AWS and Automat-it that we have actually implemented at mokSa. Hello everyone, this is Kranthi. I'm the co-founder and CTO at mokSa.ai. Before we deep dive in about what we do, let me just introduce about mokSa, what we do, and what exactly the use case is, so that you'll have a better context about how we are deploying all these DevOps techniques. So we are an AI surveillance company. We provide video analytics to our clients. Let's take, for example, a retail store wants to know what's happening inside the store in live. So we provide them analytics with suspicious activity behavior to analyze the shopper's behavior. For example, if someone is actually shoplifting something or they're doing any suspicious activity in the store. So our clients will be notified instantly using our patent pending privacy aware AI models. And not just that, we also provide all the other business strategic solutions to our clients. For example, finding out the store busy hours by analyzing store traffic, or finding or giving the insights of their employees, how effectively they're doing in the store, or if some of the locations have kitchen, we can also give them if they are following the kitchen hygiene and all. Yeah, that's pretty much about the use case. But for us, why I'm explaining all these things, for us, everything is an AI model. In an infrastructure wise, everything is a container. So all those AI models will be packaged together in a container. As Elior was explaining, we use EKS internally. So we wanted to have, so why we take the decision to use an EKS? Because at the beginning, we are using all the monolithic architecture. We have built all our AI models. We are trying to deploy all our AI models to the client locations, and for example, creating an VM instance and deploying all our models there, and sending all the insights to the front end in the database, and then showing it to the clients. It was like very cumbersome for us. So we wanted to optimize that process. That's when we reached out to AWS, and that's when we were introduced to Automat-it. And then that's when we started developing all this automated DevOps thing. So hence the title is From Code to Client in One Click. That's how we are going to be. That's what we have actually achieved at mokSa. without any manual intervention of a DevOps engineer. We're able to deploy, or we're able to onboard a client. I suppose everyone, for every startup, what it matters is like clients, right? Or the money. That's why onboarding a client at very seamlessly and very easily is our goal. And I'm going to be explaining how we actually achieve that. But before that, I wanted to address certain concerns what we are facing. For example, manual onboarding process, what I was explaining you, and they always needs a human intervention to deploy or to onboard a client, which is very, very time-taking process. And some of the clients, they don't even want to share the data with other clients, and then they want an isolated environment. So pretty cumbersome for us to maintain such environment as well. And business cost going to be so huge, and it's going to be there is so much delay, and then neglected security concerns, the data being overlapped with the other environment, and there are so many problems we have encountered. So in order to solve all those, we have created an innovative DevOps automation thing. In one click, everything will be automated and deployed onto production right away. I'm going to be explaining how and what we actually did with all our AI-powered applications onto production with a faster delivery and with a very minimal or zero manual effort onto our production cycle. So let's start with the CI/CD as Oleksii was explaining. Again, so from the developer to going to the production, it always starts from CI/CD, the continuous integration and continuous deployment, right? So we have to integrate what developer actually developed. So that's where it starts. As soon as the developer commits something onto GitHub, we just go ahead and trigger a Jenkins pipeline automatically. Again, there are webhooks that can do that. Jenkins will trigger and then package all the developer's code into a Docker container. Again, and that will be analyzed using all the security. So security, as I was saying, security is a serious concern for us. We analyze the security risk at each and every step. So right from the build stage as well, we analyze the Docker containers with the Trivy tools, and we do all the linting of the code, and just to make sure the build is proper before we even push into the production automatically. So the build has to pass in the Jenkins phase. If that fails, then that goes back to the developer, and then otherwise that will push to the ECR. Again, it's a tool on AWS. It's a managed service. You can store all your containers in it, Elastic Container Registry. All the containers will reside there with the respective version what we have pushed to Git, or that will be maintained using the versions. That's when the Argo CD comes in. So in the Jenkins pipeline, what it does is it just simply create a new version, updates in the GitHub repository automatically. As someone was asking in the questions, how the automatic trigger would happen onto production, that's where the Argo CD comes in. It keeps on pulls into the GitHub or any Git provider you might have, and continuously pull if there are any commit from the developer. That's when it'll identify a commit and then takes up the commit and then looks at the new build, downloads a new build, and then push it onto EKS cluster automatically. So you have to provide all the deployment manifest scripts in Kubernetes cluster so that it knows how to deploy your application. That's where the CD comes in. This is what the continuous deployment is. So it takes the build from ECR, identifies the changes in GitHub, and then pushes directly onto Kubernetes. And on top of it, there will be a security integrated each and every step, as I was mentioning. In Kubernetes also, we do that. There are mechanisms that we take care of it. And once that is deployed, so how it is smart in a sense, we create a separate isolated environment each and every customer. So that's a namespace in Kubernetes. If you all very technical in Kubernetes, so we'll create a namespace automatically using our script in the DevOps infrastructure, and then it'll start pushing all the models onto that namespace so that the environment is completely isolated. And we have an option to up the models and then down scale the models as well. So we know exactly when to deploy the models, where we need the models, and how to scale them as well. So it's all part of the DevOps infrastructure as well. So it's very cost effective, and we don't want to run our models all the time because some of the stores are like 24, not 24/7. So they run only 10 hours, 18 hours, and we don't want our models to run 24/7 because it's a GPU intensive task. We don't want to spend money. So that's where the cost effective would come in. So we only know exactly when to run the models at what part of the day and what time zone. And as I was saying, I know it's very cumbersome to maintain multiple clusters across the globe, but we have the clusters that are close to the client location because it's our AI models are video consuming models. So we don't want to consume the video from one part of the world to another part. So we deploy the models right close to our client so that the latency will be very less. And that is also part of our DevOps infrastructure. We make sure that we provide the time zone of the store, and then it will figure out where to deploy. And as you were saying, so this all comes to why we did this, because we wanted to onboard our client effortlessly and with a very manual intervention, and to have faster deployment on the cloud. As I was saying, so we'll have the dashboard ready, and then as soon as the client or our sales guys and then went to the store and then collect the client information, they just have to enter into our dashboard. That client information goes back into our DevOps intras. As you can see, effective code execution. There is a Lambda that keeps on looking at if there are any new client information onboarded in it. So there'll be a Python program that will trigger, and then they'll check in the DynamoDB. If there are, like, we use the DynamoDB for the client information, take the information from DynamoDB and it will trigger. For example, in AWS, you have a very useful tool called step function. It will automatically, it's something like an orchestration. So at each and every, it knows at what step what to do. So you have like very customization thing that you can do. So it'll take, and then we provide what steps that needs to perform. For example, taking the ECR, pushing on to Kubernetes, blah, 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 so on and so forth. And as I was explaining, all the Argo CD and Kubernetes, which is like part of the plan, and then they'll create an isolated environment. So that is pretty much the infrastructure that we have created, but we also secure our, like I was saying, in the Kubernetes, how we secure the environment is, so all the models and the Kubernetes run behind a private VPC, no internet exposure to any of the models. So there's no way that the data will be out in the public internet. And role-based access control is enabled, so only the respective people will be able to access to our Kubernetes or our infra with the role-based access management. And that too, it's on private side. So you have to have a VPN that is connected. Otherwise, you won't be able to access any of the resources. And that VPN is also part of our innovation that we did. And also every end, we do the end-to-end encryption with the TLS. For example, if you are exposing something on the client, then there'll be a like HTTPS for all this, so it'll be encrypted. And if you're storing some data on S3 or any other places that is client facing, we do some encryption on our side as well. And then we make sure that the data is secure on AWS. As I was saying, we are fully on a cloud-based solution that we have devised for our clients, so it is on AWS completely. And of course, there are like so many very useful tools on AWS that we are using to continuously monitor if there are any vulnerabilities or if there are any security threats or any attacks. That is also part of our DevOps infrastructure. So thanks to Automat-it, they have given us a very good infrastructure as code to monitor or to automate everything in terms of this like there's automated tasks that can be done. For example, enabling VPC log or identifying the IPs that are trying to access in, and so on and so forth. They have like very good tools that can be deployed quickly. And as I was saying, we use the Terraform, so as an infrastructure as well, so that will be automated everything. But once it is deployed, that when it comes like how effectively that we deployed, how effectively that they are working is also matters. So we have used an observability platform using Grafana and Loki and some other tools to monitor real time what exactly going on our infra at what place. For example, if there is a problem that is happening on Kubernetes side, we trigger a Slack notification, we make a call directly on of our developers, and then they'll be able to quickly log in and then identify or even mitigate that issue is. And so the instant fixes that we do, and then we will be able to see with the Prometheus, Grafana, and all the logs of our application CA model, so that we know exactly what's going on our infra at any point in time. And the alerts I was saying, that's going to be instantaneous. So Slack and the mobile, and then even we also trigger some of the emails as well. So that is an effective monitoring and observability. And how it all impacted our business. So we were able to scale it up very quickly, and we're able to save 40 to 60% of our cloud spending on AWS. And we have eliminated almost 20 plus manual steps to automate everything right from the client code to the production deployment for all the clients. And before, it used to take at least 2 to 3 days for us to onboard all the clients on our platform. At least one client on our platform, it takes at least 2 to 3 days to set up the model, create a environment, and then deploy the AI model. But with this automation, we can able to deploy a client within 10 minutes of a time. So everything is automated on AWS, and I can proudly say that that's the power of automated, or with the best practice. If you follow the right and best practices using the DevOps, I'm sure we can do so many wonders for any use case that you can discuss it. I guess that will be all from my side today, and I'd be happy to take any questions you might have. Thank you so much for this opportunity, Yav, and I think the stage is yours.
Kranthi, thank you so much as well. I mean, I'm just gonna take advantage of this moment to say, first of all, thank you for all of you, Elior, Oleksii, and Kranthi. That's really insightful. So we do have some questions. I'll start by asking, have you ever faced with something that you suggested do not rebuild to GitOps approach? Anyone who is able to address that question?
Let me take that, but before that, I would like to understand a bit more carefully something that you suggested: do not rebuild to GitOps approach. Like, you want to know like when to avoid GitOps approach in terms of deployment? If that is what you're asking? Probably yes. Yeah, we have faced some situations on our infra as well. We know, it's because deploying a GitOps is a kind of an expensive task too, but you need to make sure that when to use GitOps as well, because you cannot just use for a small thing to have an entire infrastructure deployed. For example, if you see in our architecture, we are using lambdas and Python scripts to do some small tasks, because that's where we don't need exactly a full GitOps implemented there. Again, to my understanding, it completely depends on the use case, what you're dealing with. So if there is a task that can be done very quickly using lambdas or anything, you can just simply go ahead and do it, right? But if not, if there is something repetitive that you want to avoid, if there is something that you are doing every day that repetitively, I would probably prefer a GitOps, so that you can automate it everything.
Right. Kranthi, thank you so much. Next question.
I think next question is for me as well. Interesting product you have. How frequently it must be updated with the new version and infrastructure with it? That's a very interesting question, and thank you so much for your comment. I mean, we don't technically update a lot on our, like, we don't technically go ahead and do a new version every day, because once the model is ready, and then that will be at least good for next 1 to 2 weeks. Until and unless new data comes in, we don't actually update our model. So that means we don't have a new version of the model. But if there is a client that comes in and then are subscribing to that model, that's when we deploy and go ahead with our infrastructure. So the product or the Docker container that we built is going to be very frequently being used every day, but the new versions, we don't quite build them very often. So as the new data comes in, it's a general practice in AI. So the new data comes in, you have to refresh your model. That's when we get a new version of the model, and then that's when we get a new version of our code. That's when we do deploy our versions. But that is something different with the automatic deployment and the underlying artifacts building itself. So there are two different things.
All right, Kranthi, thank you so much for your elaborated answer. Elior, I think this one is for you now. How does the out-of-the-box auto-scaling works in EKS auto mode?
Okay, that's a good question. So under the hood, it's working very similar to Carpenter, if you are familiar with Carpenter. The documentation of Automod is available in the website, and there is also a good YouTube video from the last re:Invent that explains in details how it works. But generally, if you worked with the Carpenter before, it should be like the same configuration, node pools, EC2 node class. It's the same syntax. So I will send also the link in the chat for everyone who wants more details.
That's perfect. Thank you, Elior. And I think there is another question for you, which is, what would be the recommendation for a startup who is already running on EKS and find the maintenance difficult and time-consuming?
Okay, good question as well. So if your team are working on upgrading Kubernetes components around the clock and it's delaying your time to market, I would definitely recommend considering a move to auto mode because we are talking about startups. Usually in enterprise companies, you have like 30 people of DevOps engineers that 5 of them can take care of the EKS management. But usually for startups, I would definitely consider this move. And if you already have an existing cluster in production, it's possible to migrate to auto mode. And there is also a documentation in AWS website. And there is also a workshop where you can practice before doing it in production. And I will also send the links both for the documentation and for the workshop in the chat.
Amazing, Leo. Thank you. And you're on the high road, so I think there's another question for you. Question is, what AWS service for container orchestration is better in terms of security?
Okay, so security is a big factor. It's a big thing in AWS. Both ECS and EKS provides the okay, let's separate this into two because it's a difficult question. We have EKS, we have EKS Auto Mode, and we have ECS. With EKS Auto Mode and ECS, they are pretty the same, okay? Because AWS will take care of the security. And also, of course, there are things that you should manage by yourself and you should take care of. For example, VPC, do not expose subnets and instances to the internet. This is on your control. Now, if we take it to EKS, so with EKS, you have even more responsibility. For example, you need to take care of upgrading and the AMI of instances because you may have an outdated operation system that is not with all security patches. So this becomes more complicated for a startup. So basically, ECS and EKS Auto Mode are the same in terms of security, but again, security is a big thing. That there are many factors for security. So there is shared responsibility model, and I would suggest you to look at it. Hope it answers the question.
I hope so too. This question came from Dennis, so this I hope we answer. Oh, he wrote thanks in the chat, so welcome, and Elior, thank you. Now, last question again for Elior, and before I'm gonna ask it, I'm also gonna mention that Elior, I also posted the again the link on YouTube from YouTube on the chat. The one that you shared. And last question from Vitaly is, how would you create IaaC solution for EKS anywhere? Is it possible to be fully automated?
Oh, that's a good question, but actually I'm not an expert on EKS anywhere, so I don't want to mislead you. So apologies. But that's a nice question. But usually startups like prefer to not use EKS anywhere. They use like managed solutions such EKS and EKS Automate on AWS. But I can take it offline maybe and check it for you.
All right. So I think there is one more question from Felix. Felix, I'm sorry we cannot answer it right now, like right here verbally, but perhaps Elior, if you'll be able to check Felix's question via the Q&A field, possible for you to answer it. If not, we can just take it offline after the webinar because we have bit less than 5 minutes. And I want also to go through our last and well, not most, but one of the most exciting parts, which is the online raffle. So before I'm going to move that, just making sure that you scan or saw this option to scan this QR code to contact us via website, or you can just go online and check for Automat-it.com. We'll be happy to answer any kind of question or even just forward it to either Kranthi or Elior afterwards